Welcome to this section on modeling with a context question network. This context question network is made of two inputs and two outputs. For this first input, we have the context text, and then this other input, we have the question text. And then for this output, we have the position of the first word in the answer with respect to this context. And for this other output, we have the position of the last word of the answer with respect to this context. Just like with this other input right here, we have this positional encoding with the embedding layer, which takes in the context and then creates embeddings from them while adding positional encoding. So we have this first, which gives us this output. Then from this output, we now pass this through an encoder block, which is made of several encoder layers. Now this encoder block is the same block we used in the transformer model. So basically we have that same encoder block with pattern mask, because here we may have several patterns, and with the questions too we may have several patterns. So that's why here we include this pattern mask. Then after going through this encoder block made of the several encoder layers, as we've seen in the transformer model, we now get into this context question attention layer. In this context question attention layer, we're actually coming up with a way of linking up or relating the context text with the question text. After this context question attention layer, we now pass this through several encoder blocks. So we have this different blocks. Now each of these blocks are made of encoder layers. Note that since we haven't, or since our inputs here aren't this kind of input where we could have patterns, this encoder block here doesn't necessitate a pattern mask. So we just have a simple encoder block without pattern mask, and which is similar to what we have in the transformer model. This encoder blocks too are also made of several encoder layers. Then once we've built this right up to this fourth encoder block, we now take this first encoder block, we take this first here, we take the second encoder block, we take the third encoder block, we concatenate it, and then we pass it through a dense layer. So like this, we pass this through a dense layer, which now gives us this kind of output. Now the output of this dense layer will be configured such that we have this kind of output, and similarly with this. So now we see that we have this context text, we have the question, and then we have a 1 at the position where our answer lies, and then or where our answer starts, and then sort of 1 at the position where our answer ends. So in this example, if we have this 0, 1, 2, 3, we have the third position, and here we have 0, 1, 2, 3, 4, 5. We have the fifth position, telling us that our answer lies between the third and the fifth position. And then we have this zeros which span across the context length or the sequence length. Now looking at the code for each of the blocks which make up this context question network, we have the self attention. Note that if we have this sequence which is different, which is not known, we have the pattern mask. That is, if we pass in a sequence, then we shall include a pattern mask, without which we don't have to include a pattern mask. Recall that this is done because for the top layers we don't need a pattern mask, whereas for the layers at the bottom we need a pattern mask. So that's been defined. We have the multi-head attention. We have something similar again for the sequence. In case where we actually have this to be different from known, you see we pass the sequence in here. So it's here that we actually pass in the sequence and say whether we are going to use a pattern mask or not. So again, we have this multi-head attention, which is similar to what we saw with transformers. We have this heads which have been appended, concatenated, and then we pass through this dense layer. Then following that, we have the encoder layer. Again, here we have the encoder input, we have the sequence, and then we go through the same steps we have in the transformer model. We have the positional encoding, we have the encoder itself, and then we have the top encoders. Now note that the bottom encoders include an embedding layer, whereas the top doesn't include any embedding layer. So that's the difference we have within the two. Now once we have this, we define this attention model, which we just saw on the slides. And to better understand our usage of the AND/SUM operator, supposing we have this C and G, that's C from this and then G from this. We have C of dimension, batch size, ND. Now we've taken off the batch sizes for all the different matrices we're working with. So we just have now ND, where N is the sequence length of C and then D is the model dimension which we've defined. Now we have this ND. Now G, or rather Q, is MD. So we have MD transpose, and then here we have MD. Now transposing this will give us DM. So we have ND times DM times MD. Recall we're just multiplying, or we're just trying to find the output dimension of CQ transpose Q. So there we have ND, DM, MD. ND by DM will give us NM. NM by MD will give us ND. So that's how we obtain this output right here. Now coming back to the AND/SUM operator, first we could start by saying this I, converting this into the batch dimension. So here we have the batch dimension. Then right here we have ND, and then we have MD. So our output should be ND. But for the AND/SUM operator to make use of this D coming from the, or to make use of the question, we have to like change this. If we modify this, if we have this as C, although this C and this D are the same, it's going to be forced to do the computation based on this and this. So we have B N D. So that's how we convert this, even though C and D are the same. Now suppose we had done this and that we just have this, you find that this operator could simply just use BND, because obviously the context already is BND. So the output could just be BND without taking into consideration the question. So doing this forces the operator to make use of the context and the question in computing this output, such that we have this output dimension BND right here. So with this, we can now run it. We have the model, which is a construction of what we had in the slides. We have the encoder output, which is gotten from this encoder. So we have the encoder model, which we've defined already. We have the encoder 2. Basically, this is the context right here. This is the context, and then this is the question. So we have the context, and then this one's a question. We pass this through the CG attention model. Then after this, we pass the output of this into the first encoder top. That's the encoder at the top. Next, this other encoder. Next is encoder. Next is encoder. Then we concatenate the first 3 for the start. That's a head start. And then the first and the fourth for the head end. Now, once we are done with this, we have this head start, which goes through a softmax layer, or rather, which goes through a dense layer, and then the softmax. This other one goes through a dense, and then a softmax. And then we have our outputs. Now the inspiration for this model was drawn from the QA-NET paper. With our outputs gotten and put in the right form, that's in this dictionary form, as we had defined it earlier, we could see right here we have just above 14 million parameters. Our model is now ready for training and optimization.